Hello, hello, hello. Welcome back. All right, I have a quick video today. Let's see, everything works. Yes. So I have a quick video today. I finished day 4. I decided to not record it. So yeah, just to give a quick recap, I think this video is gonna be very short. So day 4 was camp cleanup. You're essentially given a list of numbers of ranges, essentially from 2 to 4. In this example, 2 to 4, 6 to 8. In part 1, we're looking for ranges that completely consume one another. So if we look at this example, you can see that 2, 8, and 3, 7. 2, 8 completely consumes 3, 7. So, and then you have 6, 6 to 4, 6, and 4, 6 completely consumes just the range of 6. Here's a more graphical for our visual learners out there, me included. Here's essentially how you can visualize it. So 2, 3, 4, 5, they don't completely consume each other. It has to look something like this or this. So I already solved it, but I'm going to explain how I solved it. I think it was a good solution. It's more like computer science, you could say. It's essentially working with intersections of lists. And when you work with intersections, there's 3 different possible intersection types. Intersections. Oh yeah, that's not what I want. Okay. Computer science. Sets, everything computer science. Yeah, so essentially, you're working with sets. So essentially, this basic sets example is what you have. Union of set A and set B is everything that comes together, or intersection of either A or B. So that's how I thought about it. It's just, let's see. So after I read the input text, let's work with sample first. After I read the sample, I said I count because we're going to gather however many completely consume each other. This line has the ranges. So you could think about 2 to 4, 6, 8 is one line. And then I split the commas. So now I have 2 separate numbers. So what I did was, sorry, you don't have to do this. I just did it for visualization purposes so I can see it easier. I created a list of the ranges. So 2, 4 would create 2, 3, 4, 6, 8, 6, 7, 8. And then I did the intersection. So Ruby has that intersection symbol. So if you intersect this first example, 2, 4, 6, 8, I think it should return. Oh, let's try it. We'll just return here. And then we'll run it. 2022 day-5. Day 4. Day, I think, okay. So yeah, so it's empty because nothing intersects. 2, 4, 6, 8. Now I remove these and I try 2, 8, 3, 7. It returns 3, 4, 5, 6, 7. So 3, 4, 5, 6, 7 is what these 2 ranges have in common. So it returns that. So essentially what I'm doing is, let's see, let me reset this. Okay. So I'm doing the first and second. And now if that is equal to one of the 2 ranges, you increment the count. So 2837 returns 3, 4, 5, 6, 7, which is the intersection of the two lists. And the second list is one of the intersection matches either one of those two ranges. So you increase the count by 1. I think it's very like abstracted, but essentially if you intersect them and it's equal to either one of the ranges, it means that they're being consumed entirely because the whole subset is found in the other array, if that makes sense. So let me copy this example for a visual. Copy here, comment it, and then if you take the intersection of these two, it returns 3, 4, 5, 6, 7, which is equal to the second range. So increment the count by 1 because it's entirely consumed. So the intersection returns what's common in both arrays. And since this whole array is what the other one has in common, it means that it was entirely consumed. And then for part 2, you're not just looking for what's entirely consumed, you're also looking for overlaps at all. So if we open that tab we had, the overlaps is at all. So any overlaps at all. So it would be, I think it's this one. Any overlaps at all. Even if they have one item in common. For example, 5779. Like 7 is the only one they have like intersecting. So now that's counted as a whole list. You bring in everything. So to do this, let's see, part 2. If any, you intersect them, same thing. So you're returning what they have in common, the intersection of these two lists. And then if any of them intersect at any point, that's counted. The increment goes up. So we go to the sample, and in the example we have 1, 2, 3, 4. So 5779. So these two won't work. Let's see. Let's do it again. We'll just do puts here so we could see everything that has in common. We'll comment this out and comment this out. Okay. Part 2. Okay. I know I feel like this is more for like, if you obviously know how to code, I feel like this is simple for you. And you have, like, especially if you know Ruby. But yeah, so we're in here together, y'all. We're in here together. Okay. Now that is ugly. So I wanted to display in one line so we can see. I think this works. Okay. So if we compare, let me run it so it's on top. Okay. So the first line is it corresponds to the line code. So 2, 4, 6, 8, they don't intersect at all. So it's an empty array. 2, 3, 4, 5 don't intersect. 7 intersects only at 7. 2 to 8, it's the previous example, 3 to 7. 6 and 4, 5, 6. So if they intersect at all, you increment the counter. And then that gave us the solution. So for those that are curious, if I run it for the whole input, let's see. I got the 779, and that is for part 2. So yeah, that's about it. Gotta work, try to catch up. Yeah, it's only 10 days left. So I gotta catch up.